Next, the dishwasher. Now again, we have already discussed this, but as I said, there are some more things. Again, it's been shown over here because as I said, it's an equipment. So that's why here the details of this dishwasher has been given. So cold water pipe for you. Cold water pipe is pumped into the machine, I mean the dishwasher, from your home water supply. Okay. The heating element at the bottom of the machine powered by electricity. Once the temperature to a temperature of 30 to 60 degrees centigrade, an electric pump, we do have a pump also, a very small pump inside. That is from, again, we don't calculate this because we generally, it's an equipment, so it automatically comes from the manufacturer. Okay, no need to worry about this pump. An electric pump at the bottom of the machine pumps the water up through the side walls in this manner. Okay, and from here a jet of water, here from here. Okay, and this way it goes on. It is used in kitchen to clean utensils with the hot water. Sorry. So let's see next equipment over here. That is nothing but a heater. So let's see what is a heater. It is used to heat the water to meet the demand of the building, or else I can say it is used to heat the water because we do require hot water, or else this is in general, but if I say in technical, this is also meaning the same. It is used to heat the water to meet the demand of the building. What demand? Hot water demand. Okay. So now this is general example of the heater, but in heater also we do have two categories. One is individual heater or a geyser or electric water heater. One and the same thing, individual heater or a geyser or electric water heater. Some people say EWH, some people say as a geyser, some people say as a unit water heater. That means a geyser, single bathroom, single heater over there. That's it. And one more is what? Central heater. Now central heater is something else. We'll be seeing now. So electrical water heater, or I can say geyser or unit water heater, it is used to supply the hot water to one or two bathrooms, but it is not recommended to have two bathrooms. But if there is no space or there is no kind of thing to install a heater over there in the bathroom and the bathroom is side by side, in that worst case then you can size up a big heater for two bathrooms, but not at all recommended because it's a geyser and maximum capacity what we have is over here is 50 liters. Okay, like we do get from 6 liters. Nowadays we are getting instant heaters also, portable, isn't it? Online 1 or 2 liters also we are getting instant water heaters also. So this is only for what? Single bathroom, because one shower or one lavatory, that's it, not more than that. So this might be 6 liters, 10 liters, 12, 18 as per the manufacturer. And what we have observed or what we have seen is it's not more than 50 liters, and 50 liters is a very huge amount of water capacity for the heater, isn't it? Because what? We don't directly use the complete hot water 50 liters, we'll do mixing also, isn't it? So this is a maximum capacity of 50 liters. Now next, as I said, and this is how exactly it looks like, and this is very simple. There'll be two lines. This is what, as you can see over here, this is cold water in, this is hot water out. That's it. So this might be how it exactly looks like. Okay, this is two lights over here, green and red. This is cold water inlet and hot water outlet from over here. That's it. Very simple. Now, as I said, we do have one more category of water. This is centralized heater over here. So this is central water heater, or some people say as a boiler. It's one and the same thing, boiler or central heater. So the moment I said central heater, I think you can relate this because you people are mostly engineering graduates in respective fields like mechanical, electrical, whatever it might be. Central system, you know, main one source, and it will be distributed to all the things over there. Right. So the same thing over here. Now a central heater is something which is one complete heater for the complete project. So in short, I can say it is used to supply the hot water to multiple bathrooms. Very first thing, but the most important thing is what? It has a return line too. It's not so. In here we have three pipes over here. If I'm dealing with a hot water central pump, I mean central pumping system over here, hot water. So I do have cold water, hot water supply, hot water return. Make sure you write down this. We'll be discussing this and we'll be sizing this different pipes over there when we deal up with the project, because I do deal up with the project what we are about to deal with the project in further is what I'm dealing with a central heating system. Because if it was a geyser unit, it does not make sense because just in cold water in and hot water out. That's it. It's very simple and like it will be done in like this. Okay, but central system you need to think. That is the main catch over there. So we'll be seeing this. Cold water, hot water supply and hot water return. So that's what. Always remember central heater means it will be having a return circulation line. That means what? I do have a return line also. The water will be coming back. And this might go to 300 liters of maximum capacity. And you can see online over here. I do have one. What is this online? I do have two circulating pumps. Now why? First of all, is this a circulating pump online? Yes. Is this a circulating pump? Yes. Yes, it is. So I do require two circulating pumps, one for the hot water supply, one for the hot water return. Getting this? Because in supply I need to have one hot water circulating pump. Anyone is owning, I'll be getting. If there is no, then it will be returning back, right? In this manner. So two circulating pumps. Now this might be different modes of the heating. So this is one heater. Central is a gas heater. The mode of this heating is done by a gas heating element and all that. And this is electricity. As you can see, some wires and all this over here. So this might be an electrical central heater. This might be a gas. As you can see, this kind of mechanism. But the main thing is what? A central heater is nothing but serving the multiple purpose. That's it. Hot water with the return line. That's it. Now, let's talk about a grease interceptor and a grease trap. Now we are heading towards the drainage side. Now, many people have confusion that what is a grease interceptor and a grease trap. Now, let me tell you, a grease interceptor or a grease trap is something which is generally connected in the kitchen area or to the kitchen sink. What happens? Interceptor and grease trap. According to the UPC, Uniform Plumbing Code, the difference between grease trap and a grease interceptor is the flow rate of the wastewater the device can handle. Now, grease trap have a flow rate of less than 50 gallons per minute, where grease interceptors has a flow rate more than 50 GPM. Now, first of all, let me show you. This is how exactly a grease interceptor looks like. This is inlet from my left hand side and this is outlet. Here he is talking about the 50 GPM, the outlet. It might drain. If it is less than that, it is what? Grease trap. If it is delivering more than 50 gallons per minute, then it is what? Grease interceptor. So logically, grease interceptor is used for what? The high-rise buildings and all this. Now, why is being grease interceptor into plumbing, where it is being used and how it will gonna work? Grease interceptor is something that separates the grease. Now, what do you mean by grease? For example, this has been generally and most commonly connected to the kitchen sinks. For example, I do have a big building, residential, like a 30 floors of building, for example, online, and it's a residential. I do have a kitchen stack over there. Okay, one different single stack only for the kitchen drain for all the complete 30 floors. That pipe will be bringing over here and draining that water from all that kitchen sinks over here. And here I do have a partition. Can you see this online? A kind of a barrier here online, this one. Okay. Yes. And a strainer over here. Okay. This is strainer and this is outlet. Now what happens over here? Now, first of all, think in a logical manner. I'm talking, this has been only connected with the kitchen sinks I'm saying, isn't it? So in the kitchen sinks, we do design kitchen sink. It should be designed only cold or cold plus hot? Cold plus hot or hot water because I'm dealing with a kitchen sink. Where in kitchen sink, what we're gonna do? We'll be what? Washing the utensils over there. So it might be very greasy also, or it might be oily, isn't it? So we need a hot water so that it might be easily washed off, isn't it? So what happens? The water which is being drained out from that kitchen sinks, it's been collected to one kitchen single stack and it's been coming down, and that water is lukewarm or hot water. According to me, it's hot water, not lukewarm. It will be a bit higher, not that so hot. It will be hot water or lukewarm or warm water, I can say. Not lukewarm, warm water, I can say. Okay. So what happens? As per this, I know this, and that water consists of so much of oil, greasy items inside it, isn't it? And I know this, when the water is being hot, that things mixes up, isn't it? I mean, the oil and grease items or the food items or the solid particles also will be drained. For example, some things it might be drained, what has been left into the plates and all this, it will be again drained out from there, isn't it? Trying to relate online, try to relate this, okay? So now everything has been collected and everything has been drained over here. So we do have a small kind of thing over here. We'll reduce the flow and we'll deliver this. I mean, we'll discharge over here in this. So what happens whenever this is being discharged? Now, first of all, it has to fill. I mean, this compartment has to fill first of all. The moment this compartment is filled, the water will be drowning in this part. Okay. So what happens in this time? The first of all, the water came, and for example, just generalize, there is some water, okay, just neutralize everything. The example, take a glass and pour some water, and now the glass is completely filled. Now the glass is completely filled, for example, but still I'm pouring the water. What happens online? Overflows. Okay, but logically, can anyone say what happens? Say what happens? The water which is being entered previously, it will be what? Replaced by fresh water, because the fresh water will be going down and the water which has been settled down, it will be coming up and draining in the next compartment. Isn't it online? So what happens over here? But the moment continuous drain happens over there, so the old water which was warm or which was hot, and it was having everything combined in that, like oil, everything. Okay, and we know this when compared with oil and water, which has a less volume, which floats on water, oil automatically for sure, isn't it? So the moment we get the water over here, I'll be getting almost a huge amount of solid particles, like might be something, rice or whatever it might be. It will be collected mostly over here in this compartment because it is solid. So it will be settled down at the base for sure. Agree here online? Now, whenever again the same still water is coming, but there are chances, because this water is again going into this, there are chances that some food particles again, I mean the solid particles will come over here. That's why I do have a strainer over here. Okay. Next is what happens when it is been draining out in this manner. So now as this is cooling down. Now again, first of all, this water has gone here. Again, it is coming here. In this meanwhile time, the water which was lukewarm or sorry, warm or hot, it will be getting cooled. The moment it gets cooled, the oil and the grease will be separated automatically because the temperature is not with the same. And we know this, oil floats on the water. So it goes at the top. Following online. So this is why grease interceptors is being used. Why? Because this is the main cause. If you don't have this kind of things, this might create some kind of combustion also. Because of what? If we don't do this, if I do all the things in one soil stack or one manhole, if there's a huge drain from the kitchens, for example, it's a restaurant, if I don't have a different thing, if I don't separate this grease and all this, because of what? Because of this oil and grease and all this, it have some kind of chemicals produced like hydrogen or something which is not at all suitable for humans. And one more thing I would like to add over here, whenever we are sizing a grease trap, it should be vented with at least 30 to 60 centimeters. Vent, matlab that should be having an air gap. Yes, an air gap, and their air gap, I'll be having one pipe inserted in that, that is called as vent pipe, so that the combustion or the gases should not form over there. It should be continuously vented. Following online? Centimeters. Okay, so now this is going over here, and what happens? Only the water from the kitchen will be collected over here. Now everything has been separated. The solid particles has been separated and the oil and grease has been separated, and it is floating on the surface of the water for sure. Okay. Now this water can be used online if there is a scarcity of water. So this water, if there is a scarcity of water, so this water will be sent to the utility area where they'll be treating at least, because again we'll be getting some sort of particles for sure again. So this water or this line will be going back to the utility area, and they'll be again processing it, again kind of filtering it, and they'll be sending it to one tank, and that tank will be connected to the WC flushing purpose. So I could not use this for the laboratories and all this, but this can be used for the flushing purpose for the WCs. Let me read quickly for you. Grease interceptors, however, with their larger size, are installed at the outside of the building or underground. Now, this is for the central system I am saying, if it's a big, huge building. But for example, if I talk about my homes, it will be very small, and generally they are having is what some small kind of grease interceptors or grease traps, I can say. In US, I don't know. I think Mr. Robert, you can answer me. I have seen, sir, in one video that they have some grease small traps below the laboratories also, isn't it? Laboratories and kitchen sinks. Mhm. No, that is something called a, say you're saying about a mixer or chopper kind of thing where they are cutting the food items and all this. No, I have seen something, sir, which is a kind of grease traps below the laboratories and kitchen sink. Very small, very small. And that I have seen that they are having a fall out also below. I mean a kind of nut where you can open and drain it out. If there is need and maintenance, you can do that. That is, I don't, that portable kind of thing I can say, just for the house. Yeah, but just for the household. But for the bigger things, you need a grease interceptor, and that should be outside of the building, as I said, because the complete drain of that complete building over there. Got it? Okay, this is how the grease interceptor and grease trap. So let's have some. This is what it looks like. The working principle I've already explained you. Just let me read it out for you. In the most basic terms, a grease trap works by slowing down the flow of the warm or hot greasy water and allowing it to cool, as I said you. As the water cools, the grease and oil in the water separates out and floats to the top of the trap. That means of the surface of the water, isn't it? The cooler water minus the grease. That means the more cooler the water, it has been separating the grease and oil. Continues to flow down the pipe to the sewer. That means now next is what? The flow which is at the outlet. It will go to the sewer line, or if you want to reuse it, as I said you, it will go to utility area for the flushing purpose. Now exactly, just see from the kitchen sink, there is a piping over here. This is, I can say, a stack over here. Now this is example. This is not a central thing, a small kind of interceptor just for our home, for example, you can say. This is how exactly what I said. This is a grease trap for my home. So this is one kitchen sink. So the water has been coming over here. As I said, there are some barriers over there. Can you see one barrier over here? Okay, now something which is being get, some solid particles will hit this and it'll try to settle down. Okay, now when it is being there, the water goes in this way. Okay, this is being filled and the water can pass from here also because you have a little space here also. Now the water goes in this way and everything, the solid particles, the food solids, you can see it has been settled down. Now what happens over here? From here to here, it takes time, and to fill up this, it takes time. And don't worry, as the new water comes, the new water has been replacing with the old water. So old water continuously drains out because the new water is entering. Okay, and that old water is what? It is cooled down. The moment it is cooled down, as you can see, this is what yellow color grease or oil you can say. It has been separated because it is cooled now. Okay, so this is heat transfer taking place over here, I can say. It goes on. Okay, once it is being done, only the water. So now the water is being separated from the oil and grease. It is floating and the food particles also. And only the water will be sucked by this pipe, or this is one kind of thing. It's not been done. And this is only a secondary tank. They are saying it is not there, a special kind of thing. Okay, directly we'll be having this kind of pipe over here. Just for what? Just to the pipe outlet. Either it might be directly left to the sewer line. If you want, you can drain that, or else if you need, what you will be doing that you can reuse it by sending it to the utility area. But most important thing, it might combust, it might have a blast, and it happened in Qatar. So what you need to have this, as you can see, it should not be fully filled. So we need to design. This is called as water level is only this much. This is called as air gap. And you can see in this air gap, we are having is vent pipe over here. Can you see this online? Just to exhaust the gases over here. Okay, because this gases will be combustible and might have an explosion in future. Slowly. That is not at all accepted. That's why it is recommended to place outside of the building also when you compare with the central systems. Okay, same thing. One more kind of installation, how it should be done. If you can see over here, same kind of thing. Okay, a small grease interceptor over here.